Dividing complex numbers. Dividing two complex numbers is more complicated than adding, subtracting, or multiplying because we cannot divide an imaginary number, meaning that any fraction must have a real number denominator to write the answer in standard form a plus bi. We need to find a term by which we can multiply the numerator and the denominator that will eliminate the imaginary portion of the denominator so that we end up with a real number as a denominator. This term is called the complex conjugate of the denominator, which is found by changing the sign of the imaginary part of the complex number. In other words, the complex conjugate of a plus bi is a minus bi. For example, the product of a plus bi and a minus bi is the following. If we take a plus bi and multiply it by a minus bi, if we multiply the first two terms, we get a squared. Multiply the outer terms, we get negative abi. If we multiply the inner terms, we get plus abi. And if we multiply the last terms, we get minus b squared I squared. And if you notice, the two middle terms are opposite, so that we eliminate those so we don't have the I terms there. And remember that I squared is negative 1. So that negative 1 times that negative makes us a positive, so we get a squared plus b squared. So the result is a real number. Note that complex conjugates have an opposite relationship. The complex conjugate of a plus bi is a minus bi, and the complex conjugate of a minus bi is a plus bi. Further, when a quadratic equation with real coefficients has complex solutions, the solutions are always complex conjugates of one another. Suppose we want to divide c plus di by a plus bi, where neither a nor b equals 0. We first write the division as a fraction, and then find the complex conjugate of the denominator and then multiply. So here we have c plus di over a plus bi. We want to multiply the numerator and denominator by the complex conjugate of the denominator. So here is the denominator, a plus bi. And what we want to do is we want to multiply it by its conjugate. Well, the conjugate of a plus bi is a minus bi. You have to make sure that you multiply it by its conjugate in order for this to work. So what you're going to do now is you're going to multiply the numerators together. So you have c plus di times b minus a minus bi. And then a plus bi times a minus bi. And then we're going to apply the distributive property, or the FOIL method, or the box method to multiply those out. So we got c times a minus cbi plus a di minus b di squared. And then in the denominator we have a squared minus abi plus abi minus b squared I squared. And then remember that we always need to simplify I squared equaling negative 1. So we have ca minus cbi plus adi minus b times negative 1. And we have a squared minus abi plus abi minus b squared minus 1. So in the numerator, we combine the real numbers, which is ca plus bd, plus the imaginary, which is ad minus cbi. In the denominator, if you notice that these are always going to cancel out when you multiply its conjugates together, so we end up with a squared plus b squared.